Our work today is similar to yesterday. We're just going to add one new shift, and that is altering the period of the graph. So you can graph sine and cosine on those first two. Those are kind of your reference graphs. If you look at C, so before we're able to graph this, let's review where the graph actually comes from. If we look at the unit circle, and I wanted to graph, say, the 45, don't draw this yet, the 45-degree mark. How would I graph the 45-degree mark using the unit circle? Go to 45 degrees and graph the y value. So I would take that length, and I'd move that length down and put it there. Okay? So my input, my domain, is 45 degrees. And 45 degrees creates a height that I graph on this axis down here. Everybody makes sense of that, right? So what this says is, before you graph it, double your angle. So if I want to enter 45 degrees, which angle do I actually graph? The 90-degree angle. So I'm inputting 45 degrees right there. But I am not graphing this height. I'm graphing the height corresponding to the angle that's twice as big. So I will actually graph the 90-degree mark. What effect is that going to have on my graph? Well, okay, this one point is definitely going to be taller, but how about the graph overall? The wavelength will decrease, because before, my period was 360 degrees. My period will now be that's okay. Just ignore him. So it will now be, no. I'm actually going around the circle twice as fast as I used to. Right? So I enter 45, but I graph 90. I enter 90, but I graph 180. I enter 180, but I actually graph 360. So now, by going twice as fast around the circle as my inputs, when I get to 180, I will finish one cycle. So by moving twice as fast, my wavelength cuts in half, or my period cuts in half. So this mark, instead of being 360, is 180. So the middle mark is 90, and the 1/4 mark, 45, and the 3/4 mark is always the sum of the first and the second mark, which is going to be 135. And it's still from 1 to -1, and it's a sine graph. Oops, I really messed that up. Try again. There we go. So, there's a very easy way to calculate the period. You take one period, which is 360, and you divide it by A. And A is whatever number is multiplied by theta. So in this case, 360 divided by 2 gives us a period of length 180. Okay? So, letter D. I am now going 3 times as fast around the circle as I normally do. How many angles will it take, how many degrees will it take to complete one cycle? 360 divided by 3 is 120. So this mark is 120, so the halfway mark, 60, the 1/4 mark is 30, and the 3/4 mark is 90. Cosine is still bounded from 1 to -1. Cosine starts at the top. There you go. So now the graph of the cosine hasn't really changed, but the labels of the x-axis have changed. We've shortened the wavelength by going faster around the circle. Okay. What about letter E? I am now going twice as slow as I normally do, which will do what to my period? It's going to double the length of the period. So 720, the halfway mark will be 360. This one's 180. And 360 and 180 add to be 540. Still bounded by 1 and -1. Regular sine graph. Everybody get that? Okay, F appears difficult, but it's actually really simple. So I am now traveling around the circle at 3.14 times the speed that I normally do. That's kind of messy, right? So let's not think of it that way. Let's use the formula 360 divided by A. Only I don't really want to do 360 divided by A. I'd rather do 2 pi divided by A. So 2 pi divided by A, which is pi, equals 2. 2 what? What unit am I using? Radians. Now, we have never talked about single, well, not much about single radians. We prefer all of our radian measures to be in terms of pi. Pi over 2 radians is 1/4 of a circle. Pi radians is half a circle. 1 radian is roughly 57.3 degrees, but it's an irrational number. So it's not much fun to work with. So 2 radians is double 57.3. So yeah, so it's 115 degrees or something like that. But we don't really care. All we care about is the length of the period, which is 2. So my period is now 2 radians. So the halfway mark is 1, and the 1/4 mark is 0.5, and this one is 1.5. So whenever your A value is in terms of pi, then your x-axis or your theta axis is going to be labeled in rational radians instead of irrational radians. Okay? So this is a sine graph from 1 to -1, like that. Getting the hang of this? Letter G. What's going on here? It's upside down and 4 times slower, which does what to the period? Makes it 4 times longer. So 360 divided by 1/4. How do you actually do that? We invert the denominator and multiply, so it's actually 360 times 4, which is 1440. Who is a 1440 snowboarder? That's 4 revolutions. That's you? So 2 revolutions is 720. 1 revolution is 360. What's 3 revolutions? Which is 1080. It's a lot easier to teach trigonometry to skaters than it is everybody else, because they've got this rotation thing down. Yeah, they know it all. Okay, and it's still bounded by 1 and -1, but since it's a negative cosine, we start at the bottom. So bottom, middle, top, middle, bottom. So as soon as you figure out the period change, then all the rules are the same. But we'll do a bunch more examples of every type to make sure you can handle everything. What's going on here? Twice as tall. It's pi over 2 times. It's not twice as slow. It's pi over 2 times as slow, which makes pi over 2 is bigger than 1, which is faster. Yeah. So conceptually, going pi over 2 times faster doesn't make much sense in your head. But if we use the rule, 2 pi divided by a, and in this case a is pi over 2, how do you divide by a fraction? You flippin' times it. Just flippin' times. That's what Tom used to teach. Do you know Tom taught me when I was a sophomore? Yeah, he's old. So 2 pi times 2 over pi equals 4 pi over pi, also known as 4. So the length of my period is 4. So where are the other 3 marks? 3, 2, and 1. But that's not actually where this graph takes place. We need to shift it to the right one. So instead of 0, 1, 2, 3, 4, we're actually going to graph 1, 2, 3, 4, 5. And it's a cosine, but it's a 2 cosine, which makes it twice as tall. So it maxes at 2 and mins at -2. So top, middle, bottom, middle, top. Like that. Did everybody understand that? So if you don't understand the circle and moving faster and slower, throw it out. Just do 360 divided by a, or 2 pi divided by a. And that will tell you the length of one period. And then you can shift that period wherever you need to. Letter I. What's going on here? 4 times faster, which makes the period 90. 360 divided by 4 is 90. What else is going on? It's upside down and not up 2. So my center line is up here at 2. Where is my maximum? Max is at 3, and min would be at 1. And the period ends at 90, so the halfway point is 45. The 1/4 mark, not 30, 22.5. And the 3/4 mark would be 67.5. And it's an upside down sine graph, so middle, bottom, middle, top, middle. Any questions on that one? Okay, well the good news is if you get that, they don't really get any harder. It's just more of the same. What's going on here? It's upside down, twice as fast, which makes the period 180, but in this case we have a horizontal shift that's in radians. So we're going to mark it as pi. Instead of the period being 2 pi, it's now pi. So if the period is pi, the middle mark is pi over 2, the 1/4 mark is pi over 4, and the 3/4 mark is 3 pi over 4. But I'm not using those numbers. I need to shift it left pi over 2. So I'm going to move my 5 dots left how far? 2 dots worth. So 0 turns into negative pi over 4. Pi over, or sorry, that's a 2. Pi over 2. Yeah. So this is negative pi over 4. Then 0, then pi over 4, then pi over 2. And those 2 dots are no longer needed. Now, if you prefer to shift it first and then calculate them, go ahead. But I prefer to calculate the originals and then do the horizontal shift. And you might hear horizontal shifts are called phase shifts. Has anyone ever heard of 3-phase electricity? Okay, never mind. Then I'm not going to explain it. It could have been. Yeah. Three-phase electricity is when you need a lot more energy than normal. Anyway, but okay. And what else about this graph? What's the max? 1 and -1, and the graph is upside down. So bottom, middle, top, middle, bottom. Oh, you were doing so well until you fouled it up. All right, letter K. What's going on here? This one's actually kind of tricky. Yeah, we're going to shift it to the right 60, which makes things messy. So before we graph anything, let's think through it. What's the period? 180. So if the period is 180, how far apart are my critical points? So the halfway is 45 is 90, and the 1/4 is 45. So we know that each critical point increases 45 degrees. Where is my first critical point going to land? 60. So in this case, I would actually graph the 60 first, and then how are you going to calculate all the others? Just add 45 until you get to the last one. So 60 and 45 is 105, 150, right? 195, and 240. And that's it. So 1 to -1, it's a sine graph. Looks like that. Well done. Letter L. What's going on here? 3 times as tall. The period is 180. Shifted to the left 45. So if my period is 180, how big is each mark? 45. I was so nice to you on this one. So it's 45, 90, 135, and 180. And I'm going to shift it. Can't pull it both directions. You got to pick one. Left, 1 mark. So it's going to start at -45. We can cross off that 180. It's a cosine graph that maxes out at 3 and at -3. So we'll graph top like that. Okay, letter M. What's going on here? Half as tall, upside down, down 1. If we travel 4 times faster, the period is 4 times shorter. So the period in this case is going to be 90. And I'm going to go down here to -1. That's my center line. My period ends at 90. What's the halfway mark? 45. The 1/4 mark? 22.5. And the 3/4 mark? 67.5. Where's my maximum? -1/2. So this is the maximum. Where's the minimum? -1.5 or -3/2, however you want to write it. What else do we need? It's an upside down cosine. So we start at the bottom. Bottom, middle, top, middle, bottom. This isn't too bad, right? I hoped breaking it up into 3 days would make sense. If I try to teach you all of it in the same day, I'd pull what little hair I have left out of my head. Okay, what's going on here? Twice as tall, upside down, up 1, 3 times as long. So if we go around the circle 1/3 the normal speed, it will take 3 times as long to complete 1 full period. So 360 times 3 is 1080. Oh, but wait a minute. Where's the center line? Center line is up here at 1. Where's the maximum? At 3. Where's the minimum? -1. So the period ends at 1080. So the halfway mark would be 540. The 1/4 mark would be 270. And the 3/4 mark is 810. And it's a negative sign. So middle, bottom, middle, top, middle. Any questions? Okay. Good luck.